I live in Portland, Oregon, so shout out to Pacific time zone. And I first got started with stream processing in 2017 when I was a software engineer at a large data analytics company. My team there built that first stream processing data pipeline using Flink. And that's where I first got to know my current coworkers, is when I became a regular speaker at their conferences while I was working on that project. And then I just got completely hooked. Awesome open source community around Flink, and here I am. So definitely check out that community. Additionally, I am taking over this talk from Marta Pays, who was on my team but has since moved on to a different company. So I want to make sure and give her a good shout out for some of the visuals and the fantastic demo that she put together that you'll be seeing later. So today I will start with why to pair Flink and Pulsar. And this will also include a brief high-level introduction into Flink in case anyone's not familiar. I promise it'll be short, or at least sweet, maybe. And then I'll go into the connectors and support for the Pulsar and Flink relationship over the last years, so I can get you all up to speed on what that relationship looks like and how it's continued to evolve. And lastly, I'll go to where SQL into this relationship, and that's where our demo is going to be as well. So, what even is Flink? Flink is a powerful, stateful, fully distributed processing engine for both batch and stream processing, or more precisely, bounded and unbounded data streams. Flink's strength is in its scalability, its high performance, so think computations done at in-memory speed, and various features like exactly once guarantees and a robust high availability option that allow for these high levels of very granular data accuracy and data reliability. Additionally, there is an ever-growing ecosystem around Flink of libraries, connectors, other features, and partnerships with other complementary tools and software that have really enabled it to fit into a pretty wide variety of use cases and into Specifically, it can be run on basically all environments, so Hadoop, Yarn, Mesos, Kubernetes, and can also be set up to run as a standalone cluster. So it's very configurable, and its timing and state features allow even further flexibility for being able to run it on all different types of applications. And of course, a total bonus, it has this super adorable squirrel logo. So here we have an example of what it looks like for Flink handling a batch and a streaming scenario. Left is our example. We have recorded or historical events. And although these are queried periodically, Flink's real precision time capability enables this to be done quite efficiently. And on the right, we have the more streaming scenario, which relies more heavily on Flink's internal state functionality. And this should give an idea for what Flink's most typical use cases are, which tend to be event-driven applications, data analytics applications, and data pipeline applications. And as part of this ecosystem, Flink has a series of APIs. The higher level the API, the more concise, but the less expressive, and vice versa. So on the most expressive is on our lowest level with process functions. It's Flink's precision timing, event, and state-related functionality. On the mid-level is the data stream API, which powers the unified batch and streaming functions. So this is going to be anything related to windowing, exactly once, etc. This is also where all of your maps, reduces, aggregations, all of that is going to take place. And then the table API and the SQL client make up the highest level, so our relational APIs here. And of course, that's what we're going to be getting into in a bit later. So, great. Why use it with Pulsar? We get this question a lot, partially because Flink and Pulsar do share functionality, but it's actually very common saying that, I promise. So, not much about which one's better or even which one's used for different scenarios. But really specifically, both projects share this common understanding around the idea of unifying batch and streaming under one system. So on the Pulsar side, streams are seen as this unified view on data. And on the Flink side, batch is seen as a special case of streaming, or like a subset of streaming. So on the Pulsar side, this relates to where data in Pulsar is abstracted as infinite segmented streams, with those two levels of abstraction, a pub/sub messaging layer for streaming and the layer for durable storage and offloading. So a data processing engine can use either level to process the data in the most efficient way. And that's where Flink comes in. So Flink being a streaming first data processing engine that, can also do very efficient batch processing. But taking a bit of a step back, so why is it important to have this solution? So processing allows users to reuse their code and logic across both batch and stream processing. And of course, that makes it easier to integrate into different applications or systems. But moreover, it helps ensure that semantics, so you don't have to learn a completely new API for each processing mode or each layer of abstraction. It means you can simplify your operations by keeping configurations and processes systems. And it enables people to mix historical and real-time data. So if you want to bootstrap a job with historic data and then switch to consuming it as a stream once you've caught up, then you're golden. It's a great system for that. So the main differentiating use case for using that Flink and Pulsar combo is that part about simplifying the process of building a unified data processing stack. For example, instead of architecture with data stored on Hadoop to process data in batch, you can just combine just these two to get a single stack for storage and processing of both that real-time and that historic data. So just all in one place, super simplified. So with that, a little bit of the history. So looking deeper, so the users and around both Flink and Pulsar, on both sides of this, started to recognize the potential of the, so predating 2018, but in 2018, efforts were made on both sides to realize and find that relationship. And this is when the first work was really done on this back in Flink 1.6. This version was just kind of a basic connection between the two and wasn't yet fully harnessing the power of Pulsar's storage system. So a lot of work went into really understanding what a tight integration between the two of these systems and what that would look like. The first thing was to bring schemas into the picture and to make the table API and SQL as truly first-class citizens. And this allowed you already to pretty easily run Flink SQL queries on top of Pulsar with very minimal configuration. And then more recently, the Pulsar community worked on advanced features. So like enabling end-to-end exactly once guaranteed and support for others. So for instance, and interpret change logs. There's also a pretty good number of improvements for the Pulsar Flink connector in SQL. So ability to read and write metadata from Pulsar messages. So this includes event time, keys, and customized fields, things like that. And all of this has really led up to where it is now. So the Pulsar Flink connector provides this elastic data between Pulsar and Flink, allowing Flink to read and write from and to Apache Pulsar, which I think is really just the most concise way of explaining it. And the goal there, and really what I think it's gotten to at this point, is that connector really enables you to just be able to concentrate on your business logic without worrying about all the storage details and all of the overhead. Okay, so now that we have an idea of the Flink Pulsar relationship and why you want to use it, I want to briefly say why we're focusing on Flink SQL and not everything else in Flink. So, and I feel like we get this question sometimes because it's like, okay, there's so much with Flink, there's so much going on. Why am I focusing on the SQL part here? And I think that almost kind of answers itself. There is so much going on in Flink, and that is awesome, and I love that. And it's such a powerful and flexible tool, but it also means that it's really nice to have this option where you can truly just jump right in and start building something that is really going to leverage Pulsar and Flink together. Whole deep dive into Flink. So we love the deep dive. That's great. If you're a Pulsar person and you want to just get in there and start building quickly, and you want to be able to, later deep dive into Flink, and that's great. It's a great way to maintain that flexibility and still be able to jump in just real fast and get started. And as I mentioned earlier, so we have all these APIs and they've got varying degrees of expressiveness and conciseness. But for your high specific use cases, anything that's going to be closer to that relational way of thinking about your data, it's just so much more convenient to express problems in this rapid prototyping language like SQL and just let all the heavy lifting be taken care of for you. So again, this is the perfect use case for this, to be able to just avoid all that overhead. So again, being able to focus on the logic and just meeting your business requirements and not have to focus and maximizing developer and autonomy, basically making an advanced stream processor like Flink more accessible for everyday use. And there's some pretty cool real world use cases where we've gotten to see a couple things. We've just highlighted 3 here, and these are some of the ones that I personally are super exciting. So being able to use this to much more easily and efficiently build unified pipelines for online and offline model training, to be able to independently build end-to-end streaming analytics pipelines without not even having to depend on a full engineering or operations team, and more easily generating features for machine learning model training. So again, it's all about that autonomy too. So with all that though, what is actually different about running SQL on top of a stream? So here's an example of a regular SQL engine, regular database, where executing your query at a certain point in time. And the engine takes a snapshot of the table at the time the query was run, and then computes the based on that static snapshot. Then the query terminates. In streaming SQL, the query is continuous. So and then whenever data is added to the table, the changes are continuously ingested and results are also continuously updated. The query keeps on running and never finishes. Really can't do the job. So in a nutshell, SQL gives you is this high-level relational-like way to query data streams using a language that you are a little more likely to already know. So again, you're not having to depend on, okay, we either have to do Scala or Java or Python, or if you're integrating this into an existing system, you're not having to switch or learn a whole new thing. It's likely you're probably already using. So it's optimized to handle that batch and those streaming workloads in that unified way. So a lot of times, if you want to use the exact same query to process real-time data and say maybe like a file stored in S3 bucket, or in this case, you can switch between processing Pulsar streams and segments without changing any of your logic. So just, making it super easy. And besides all the operations that you might already be familiar with, joins, your aggregations, your filters, it also has support for all of these advanced operations. So like time traveling, change data capture, things like match recognize, among many others, actually. And with something as I'm going to say simple, I don't mean simple as in, there's a lot of very advanced things that you can do with it, but simple as in you can just get started really quickly. With something, you can build applications with the same scalability and consistency of any other Flink program. And you have access to that entire Flink ecosystem around it that makes it really easy to write that end-to-end streaming applications. And of course, do all of this using just SQL. So, okay, so I think we now have all the context we need for our demo. And for this demo, we'll be using the Pulsar's built-in connector for the Twitter Firehose. So for anyone not familiar with that connector, the Twitter Firehose source connector receives tweets from Twitter Firehose and writes for topics. And in this example that Marta put together, we are checking for Twitter topics related to gardening. So this is step 1. And we just got 5 steps here, so we're keeping it nice and streamlined. I wanted to make sure you can go home and just be able to just jump right into this if you wanted. Then, of course, we have step 1B. So got to do a quick check after creating that source that we're actually getting some data in. So data, yep, check. All right. So next we can start the Flink SQL client, and we're using the Pulsar catalog to access the topic directly as a table in Flink. So that might sound a little complicated, but as you can see here, and I'm going to try to leave this up a little bit so you can see the full thing. It's actually pretty straightforward. This will also make things a lot easier in a moment, so you'll see that in a second. And I've included here the catalog DDL over here to the side, so just so you can get a much more granular look at just what that looks like. And you will definitely know when you're in the Flink SQL client. We have this lovely gigantic squirrel, so you will absolutely know if it's working. Okay, but plot twist. Then you find out that most Firehose events have a null created time. So this is just part of the Firehose system. It seems like kind of a bummer, but luckily there's actually a fairly easy way. So again, easy way to resolve it. It's so easy. I've just included it as step 3. So we have this example here, and one way to get that relevant timestamp is you can just use the Pulsar metadata to get publish time, so your ingestion time, so timestamp of when the message was published. And the cool thing about having integration with the Pulsar catalog is that you're now able to with the exact same schema as the original topic by just using create table like, as you can see here. So in the DDL, you see we're using the Pulsar connector, tapping into our tweets topic, and then we're using the JSON format to deserialize the events. So same as before, I just submit the statement SQL client, and we're good to go. And because we're using publish time and defining it as a watermark, we now have that notion of time in our application. So again, it may sound a little complicated, but if it's very straightforward. And again, we still have just 5 steps in this whole process, even getting around that Firehose issue. So yeah, nice and straightforward. And just closing that loop, so you can create a sync table backed by a new topic in Pulsar and insert into it using a simple windowed aggregation. You can see the query is pretty much something that you could just run in a regular database. Using standard SQL, doing some aggregation on the total number of tweets. We've got a window of 10 here. So once we submit this query, it will continue to run continuously and continuously sync those results to Pulsar. So in our final step, we get this final count of the number of tweets in this category in windows of 10 seconds, which is based on event time. And that's it. We're done. So again, nice and straightforward, really easy way to just kind of jump in there. And like I said, of course, there's so much more to explore with Flink SQL, and particularly with what you're able to do if you leverage Flink SQL and Pulsar together. And if you want to check out the Flink SQL cookbook, this is where we regularly share hands-on examples, patterns, and use cases for Flink SQL. There's really fun stuff in here that a lot of my coworkers have put a lot of really nice time and effort into, so I definitely recommend it. And with that, here is a courses for one page, but I promise that I will have a way for you to easily grab that, which I do right here. So feel free to grab this QR code. I'll try to leave it up there for a moment. And I will be adding links and resources to the site that links to. And with that, thank you all so much for coming, and a huge, huge thank you to the Pulsar conference staff. They have been absolute heroes organizing this all, and hope to see you all at the next one. Cheers.